We also want to understand the difference between crystalline and amorphous. So this slide demonstrates that. So here I've got water, and this shows the three-dimensional arrangement of water molecules. So why is it that water molecules arrange in this specific organized three-dimensional arrangement? It's the polarity. So one molecule is partial positive here, has to attract to the next molecule's partial negative. And the organization allows it to maximize the number of those attractions that form. Right? So in a liquid, when the water's sliding past one another, a molecule of water maybe can only form one or two attractions at a time, and those might break, and then it would reform somewhere else. That only happens if there's enough temperature or motion for them to keep breaking and forming their attractions continuously. But if I slow it down and cool it down and make it freeze, then each water molecule which has the capability of forming 4 hydrogen bonds, will organize into this arrangement where it will form 4 hydrogen bonds. So if I look at one on the interior here, the oxygen is forming a hydrogen bond to this hydrogen and to that hydrogen of 2 neighboring molecules. And you can't see it, but then the hydrogen, each hydrogen on the water is forming a hydrogen bond with 2 neighboring molecules. So each water forms 4 hydrogen bonds in this organized structure, 4 hydrogen bonds with 4 different molecules. And that network really holds it together pretty effectively. Right, so when you have a crystalline structure, that usually results, the organization, which is what makes crystalline versus amorphous. They're different because crystalline is organized, amorphous is disorganized. That organization that makes something crystalline is usually due to forming up larger attractions or a greater number of attractions. And it also requires the molecules to be regular in shape so that they can pack in an organized way and make those attractions. So you usually have molecules that are spherical or disc-shaped or rigid rods, or something like the water is just like a little bit of a V shape. If every molecule has the same shape, then they can easily pack in next to one another and form these attractions and allow the attractions to take hold. So molecules that don't usually form crystalline structures are molecules that have irregular shapes. So flexible, long chains of molecules that are flexible, like spaghetti. Right? If you have spaghetti noodles that are uncooked and they're in the box, they line up right next to one another, right? Because they're all rigid. And it's easy for them to just pack into that box in an organized way. But once you cook them, they're all flexible. And you make a plate of spaghetti, they're not going to organize in any way, right? So that's what this picture is meant to show. If we've got long chains and they're just randomly coiled up, they're not going to be a crystalline structure. So if you imagine on one of these chains that I can form partial positives and negatives along the chain, it can form really strong attractions with the neighboring chains because it might have lots of sites of partial charge on its surface to attract the neighboring molecules around it. But if it's long and flexible, it's never going to be organized. So the difference between amorphous and crystalline is that whether it's organized. If the long chains start to line up in some regions, I can have some areas of a solid that might be somewhat crystalline and other areas of a solid where it's not very organized. So that happens, and that happens a lot in plastics and polymers, and the properties of a plastic, whether it's hard or whether it's soft and flexible, have somewhat to do with how much of the area in that plastic is actually organized and lined up a little bit versus how much of it is totally amorphous and disorganized. So it's the ability of the molecules, if they're rigidly formed or regularly shaped, they can line up and maximize their attractions. Then we expect it to be more crystalline. When you form a crystal, there's a few different ways the particles can be organized. The type of organization is called a lattice. Lattice is a word that refers to organization. So the unit cell is the smallest part of that crystal that when you put it with other equally sized parts, it's repeating. Right? So if I take a large extended organized structure, and I just take the smallest unit of it that's repeating over and over again. That smallest unit that's repeating is called the unit cell. And so this has a specific lattice because the atoms are organized in a specific arrangement. So this is like a cubic lattice, right? It's shaped like a cube. There's lots of different types of lattice. The water molecules don't form a cubic lattice. They form a more hexagonal type lattice. Right? So you can see the hexagonal shapes there. So the field of studying the shapes of crystals is really detailed and complex. We're not going to get into much of that detail at all. This just shows you a few of the different types of arrangements that atoms can have. So why would some atoms organize in this triclinic arrangement, whereas others might organize in a hexagonal arrangement or a rhombohedral arrangement? Why are there different ways to organize atoms? Yeah, because some molecules have different shapes. One molecule might be long and it might have a partial negative and partial positive on opposite ends here. Another might have more spherical shape and have partial charges in different locations. So the reason that things will organize in a specific unit cell is so that the opposite charges can line up and make the attractions that even hold it together. Right, so because we have different shaped molecules that put their partial charges in different positions to attract to the neighboring molecules, the molecules organize in different ways. Right, so you should have a general sense for that. I'm not going to ask you specifics about these particular shapes, but you should know that the different shapes result from the different shaped molecules, and they result because the molecules need to organize in a way to maximize their attractions to the neighboring molecules. We're not going to talk about coordination numbers. We can skip over that. In cubic cells, there's 3 different types, but not going to ask you really about the details there. Again, it's just a way to get the molecules to organize to maximize their attractions with one another. And then you can see that they kind of line up in rows and columns to make those attractions.